Hello. So this is our first attempt on seeing if I can upload online lectures that can maybe help you guys if you're either absent or at the at-home days if I need to introduce new material. We're going to see how this goes. This is the first trial run through. I'm pretty excited. So this topic today that we're learning is on measurement and the metric system. For all of our notes lessons, we do have a PowerPoint that goes along with it. A lot of times in my class, I fill in the notes with you guys because a lot of times it incorporates some type of an activity, and I find that me actually demonstrating it and writing it with you helps y'all kind of learn a little bit better. With that being said, everything will be on Google Classroom, the PowerPoint, a copy of this physical note page. If you are absent, you can print it off, and then hopefully a video of me explaining and going through that. I'm hoping that that kind of seamlessly makes the course a little bit easier for all of us and provides you guys some support, especially on those at-home days of knowing what to do and where to go. Anyway, so let's get into it. So I'm really excited. Unit 1 is about safety, which we have already learned, and all of the math skills. So we're going to hit it strong today. Hopefully we're starting off with something that you guys are already familiar with. We've got measurement and the metric system. So as we talked about last time, we know that chemistry is the study of matter and the changes that it undergoes. And as a definition, remember, matter is anything that has mass. We kind of confused with the term weight. They aren't technically the same, but that is for your physics teacher to unpack. But mass and takes up some amount of space. We know that the measure of the amount of space something takes up is the object's volume. So basically, it has mass and volume. Okay, now studying chemistry, we study it with numbers. We don't say, oh, this chemical reaction was cute or funny or had 3 legs like we do in biology, okay? We measure things with numbers. And as a result of that, we need to make sure that our numbers make some sense. So chemistry studies not just matter, but the changes that matter undergoes. To be able to understand if matter has changed, it's critical that we be able to measure these changes accurately. Therefore, measurement is the key to study of chemistry. Okay, so this brings us into the SI system, otherwise known as the metric system. So the most common system of measurement in the world is the Système International des Units. I do not speak French. You guys probably know how that sounds better than me. Or to abbreviate, like the dumb people in the world like me who cannot pronounce words, SI system. Now, it is basically the metric system with some minor changes, and those minor changes will not seem at all interesting or, relevant to you. It'll seem just like the metric system. But the 2 main reasons why scientists use the metric system, or why it's so common, is it uses this really fancy decimal system. It is its foundation, and it is very, very, very convenient to convert from one unit to another. And on top of that, it only uses one, what we call base unit, to represent each different property, whether that be mass, volume, length, etc. And we'll talk about the different base units for each property over here. But something funny to kind of talk about with the metric system is that the US is one of the few only countries that has not switched over to metric completely. We do dumb things like measure length in like feet and miles, which is not moving a decimal around, and I do not know why we are doing that because that is super confusing. We do like for volume, like quarts and pints and things, and I've been in the science game long enough that I don't even know how many quarts are in a gallon. I think that's 4 though, because a quart, right? That's 4. All right, you're not even here to respond to me, so I'm just gonna look like a dummy if I'm wrong. And that's going to be fine. Okay. However, in science, thank goodness, even U.S. scientists do use the metric system because it is an international representation of measurement. Okay. So like we mentioned, the SI system is fantastic because it has only one base unit for all of the properties. For mass, we use gram. The symbol is a cute little G. For length, we measure in meters. The symbol is a cute little M. The volume is liters. Capital L. Time is seconds, or not capital, lowercase s. Temperature is in Kelvin. No Fahrenheit, babies. We are not doing that here. We are doing Kelvin, and that's a capital K. And then the amount or the number of things, specifically in sciences like chemistry, we use a mole. And the abbreviation is, not that stretch of an abbreviation. We've just removed the E, but that's a mole. And y'all are like, what the heck is a mole? Welcome to chemistry. We're not going to get too deep into mole until a little bit later in our course. But the mole is a unit of measurement used in chemistry when talking about very large amounts of a substance, such as the number of atoms in a sample. Okay, this is wackadoo. 1 mole of anything is equal to 6.02 times 10 to the 23rd particles. That is a number written in scientific notation. We're about to talk about that here in a second, but you'll realize that is a ginormous amount of particles in every 1 mole. And we'll talk about why that's important a little bit later, but I want to get into conversions within the metric system. Okay, metric prefixes. Oh, let me focus a little bit. We got a little bit crazy. There we go. All right, so a prefix can actually be added to any one of these base units to produce a multiple of whatever that original unit is. And the cool thing is that all of those multiples are integer powers of 10, okay? So for example, a kilo right here means a multiple of 1,000. So therefore, we can make the statement of something like meters, or 1,000 meters is equal to 1 kilometer. So once again, we have all of these prefixes. We got giga, which is like 10 and 90, or 1 and 9 zeros followed it. That's a lot. We got mega, which is 1 and 6 zeros followed after it. We got kilo, which is 1 and 3. We got hecto, which is 1 and 2. We got deca, which is just 1, or 1 and 1 0. I'm confusing myself. I'm going to make this a little bit easier here in a second. And then the base is your 1, where we are standard. And then we got everything smaller, deci, centi, milli, micro, nano, pico. We can go even crazier than that. But all of these are integers of 10, which is super convenient, okay? Now, I look at this chart. You will go online and find, show me the metric system, and you will see a bunch of different charts that they try to help kids be able to convert back and forth. And I don't know about y'all. I look at this and I'm like, that is a lot of numbers and a lot of like little exponents, and I'm already confused. We're going to break it down in a little bit easier of a way. But the main thing here is I want y'all to see that that base is right there. And remember, we have our special base units, right? For example, like grams, meters, liters. So the interesting thing is that every one of these little abbreviations, if I'm representing a higher value or a lower value than that base section there, I'm going to be adding that prefix onto that base symbol. So for example, if I were looking at, if I wanted to say kilograms, I would put the little K and then the grams after it, right? If I wanted to say millimeters, I would put the milli, which is an M, followed by the symbol for meters. Yes, real quick and easy way to visually represent that unit and what it means numerically for measuring things. Cool. So, or we can think about it this way. I like to think about it as like a stair-steppy thing. So my base is up here. Here are my bigger metric prefixes, units, the kilo, hecto, deca. Y'all, we do not use deca. Let's be for real. Sometimes you'll see deca with a K. Sometimes you see it with a C. Either is fine. I do not care. Okay. And then we have our smaller units down here with, once again, our most common base units that we have here. It says to convert to a smaller unit. Let's see if I can zoom in without it getting too close and crazy. Oh, that was zooming out. Let's see. That's much better. Now focus. Let's try again, focus. Well, it's a little bit fuzzy. That's okay. We'll have to deal with it. But this says to convert to a smaller unit, you're actually going to move the decimal place to the right, or you can multiply by whatever factor of a 10, 100, 1,000, etc. that prefix represents. And if you're moving from this way to convert to a larger unit, you move the decimal place that way, okay? Or you can divide by whatever that multiple of that 10 integer is. So if you wanted to convert from kilo to whatever the base unit is, you would pop down 1, 2. It took me 3 places to get there. So that just means I move my decimal 1, 2, 3 places that way. If I'm trying to go up the staircase like milli to base, that takes me 1, 2, 3 places to get to the base. But this time I'm going in the opposite direction. So I move my decimal 1, 2, 3 places in that direction. Okay. Now this, for some reason, is a that representation is much better than this representation if you're like me. But still, I get a little bit weird, especially when we are maybe considering stuff that's higher than kilo, like my megas and my gigas, and stuff that's smaller than my milli. I still get a little bit freaked out. So on the back of y'all's page here, you guys have something that I created, and it may or may not be helpful at all to you. I find it helped me a little bit. But one thing that is going to help you guys, I think, the most is y'all are going to have to know the order of all these prefixes. And I do not like to memorize. That sounds terrible for my brain. So you think about this little analogy, acronym, I don't know. King Henry died by drinking chocolate milk. If you've noticed, I've underlined the first letter of each one of those words, and that kind of helps you guide you into which prefix that represents. When I'm first kind of learning and getting comfortable with the metric system, and when I'm getting tested on it or quizzed on it, and I know I need to know the order of the prefixes, it takes me 2 seconds up at the top of my page to just blast out KHDAB for your base, DCN. Then I can actually have my own little metric chart where I can practice with my fingers and counting how many places it's going to take for me to convert from one unit to another. Very quick, very easy, and in fact, you guys have a homework assignment on metric conversions in our and scientific notation practice. I put the chart on here that we talked about now, but you know what? Might get used to, since you're about to be quizzed on it, just writing the King Henry died by drinking chocolate milk. That way you're just ready to go, because we love that. Okay, so this is the one that I created, and it creates a little bit more of a broader scope of some of the bigger and smaller units in the metric system. If you'll notice this, the main ones right here I've bolded because these are the ones that are by far the most common, okay? And once again, if you move this way, you're moving your decimal this way. If you're moving this way, you move your decimal this way. Now, one thing to keep in mind, if you've noticed here in between milli and micro, I have these two blank spots because there is actually a 3-space gap in between milli and micro and nano. If you'll notice, it goes 10 to the 3rd for milli and 10 to the 6th for micro, and then 10 to the 9th for my nano. If I wanted to go farther, I could go 10 to the 12th with pico, but we're probably not going to be doing that in this course unless I feel really mean, particularly one day. But I don't anticipate that happening this year. So that means that you've got to accommodate for that. I do not even know if somebody has given a prefix for these invisible units. I actually tried to look it up before this, and I did not find much information, so apparently they are not important enough to be included here, but we do have to accommodate for that. So if I were needing to convert between milli and micro, or going from a milligram to a microgram, I would have to move my decimal place 1, 2, 3 times over. So that's important to keep in mind. Okay, so the theme here is we're just moving the decimal. Moving this way, big to small, decimal moves that way. Moving this way, small to big, decimal moves that way. Great, that's fun. Let's practice. So I'm giving y'all some practice problems here. So what we have is we are converting from milligrams to grams. Now, instead of me doing this business and making you guys dizzy, I'm just going to blast out my King Henry died by, so once again, that's my base, drinking chocolate milk. Yes? So I'm going from milli to grams. Grams is a base unit. So if I'm noticing, I'm going to move my finger 1, 2, 3 places that way. That means my decimal moves 3 places that way. Well, here's my cute little decimal. He's ready to move now. So we go 1, 2, 3. Uh-oh, what the heck? I have gaps. You fill in zeros where those gaps are, okay? So that means I have 1, 2 zeros that I'm going to have to fill in there, if you guys can kind of see that, right? So I'm going to come over here and put my decimal, and then those zeros, and then that 1, and then that 2. So that decimal has now effectively moved from where it was in the milli location to over here representing for its grams location. Now, something that I find to be helpful is to maybe pop a 0 out there in the front. It does not matter. Both answers would be correct. But for me, I'm like a weird person. I think visually that looks a little bit prettier. I will take either answer. If you're concerned that maybe your decimal is too small and I may not see that, like that's kind of a heads up to me. Like, woo, you know, I can kind of see and try to locate that decimal a little bit quicker. Anyway, so that's our first conversion. Next one we're doing is we are going from centimeters, so centi is right there, to millimeters. Millimeters is, oh, right there. We're not going very far, but I'm going to make sure that I'm going in the right direction, because sometimes you guys get real wild and you're like, yes, got it, one place, and then you go the wrong way. So that's why writing this chart on your paper totally helps. So we go centi to milli. So I'm moving one place, that direction. Here's my decimal. I'm ready to move him one place in that direction. So now we just have 63 millimeters. Love that for us. Okay, next one. Going a little bit quicker now because we're building up some confidence. We're going from meters to kilometers or kilometers, however you want to say it. So meters is one of my base units, and I'm going to kilometers. So that is 1, 2, 3 places to the left. That's the left. I'm left and right confused. I do not care if y'all are like, well, that makes the letter L. Yeah, I two places to the left. 1, 2. All right. Six. A little bit more. 7, 8, 9. We are moving that decimal 9 places to the right to convert from meters to nanometers, right? So, oh my gosh, I'm like blah, blah, blah. So I'm going to know that the first 2 of those 9 places are going to take care of the 7 and the 5, right? So that means I have 7 more zeros to add after that, right? 1, 2, 3, 4, 5, 6, 7. We love that. Now that's a correct answer. I know y'all are like, where are the commas? The commas are fine, and they are probably helpful to me as your grader. So if you want to pop them in to make this number look a little bit less scary and more familiar, that sounds great to me. So once again, you get a comma after every 3 digits, right? So that is like a big, is that a billion? That's 1,750,000,000. I think. Now also just keep in mind there's not one of these on this page, but you may on your practice assignment that you have for homework need to be able to hit stuff that's outside of the base, like going from hectoliters to kilo or centiliters or kilograms to milligrams. That is okay. You just count how many places it takes for you to get there, and you guys will be fine. and it'll be fun. Okay, so that's my lesson on metric system and measurement.